Assalamualaikum. We are from F4 AS120514 class. We are going to present about semiconductor for CHM361. Before we explore the world of semiconductor together, let's get to know our group member. Nur Shazila Sofia binti Muhammad Afni, Siti Syuhada binti Sultan, Nurin Haflin binti Muhammad Mizan, Nur Iliana binti Saudi, and I am Ayuni Afifah binti Ibrahim. Moving on to table of content, we are going to discuss about objective, introduction, category of semiconductor, N-type and P-type, example and application, conclusion, last but not least, reference. Without further ado, let's begin our presentation. 5 objectives that we need to achieve by the end of the presentation. Number 1, to understand the basic concept and importance of semiconductor in electronics. Number 2, to differentiate between intrinsic and extrinsic semiconductor. Number 3, to understand the formation and characteristic of N-type and P-type semiconductor. Number 4, to explain the formation and functioning of P-N junction. Number 5, to identify the application of P-N-type semiconductor.
Next, I will present about introduction of semiconductor. What is semiconductor? Semiconductor is material that have electrical conductivity between conductor and insulator. Conductivity in semiconductor is sensitive to temperature, magnetic field, and illuminations. Next, semiconductor is essential components in electrical circuit because of their reliability, compactness, and low cost. Next, resistivity level range in semiconductor is 10 and 104. Common material we use in semiconductor is silicon and germanium. Both of these have 4 valence electrons. Silicon is widely used in semiconductor because of their low liquid current. Next, semiconductor have 2 categories. The first one is intrinsic and extrinsic. For extrinsic, we can divide into 2 types, which is N-type and P-type.
Next, we move to the category of semiconductor. Semiconductor have 2 main categories, which is the first one is intrinsic semiconductor. Intrinsic semiconductor are basically pure semiconductor materials, which means they don't contain any impurities or any dopants. Their electrical conductivities comes from thermal excitation. So when the temperature rises, some electron gain enough energy to move from the valence band to the conduction band. In these materials, the number of electrons is equal to the number of holes, and both of them act as charge carrier. Because there are only limited number of charge carriers at room temperature, intrinsic semiconductor usually have low conductivity. Common example of intrinsic semiconductors include pure silicon and germanium. Essentially, intrinsic semiconductors help us understand how semiconductors behave without any impurities, and this forms the foundation for understanding what happens when dopants are added later. The second category of semiconductor is extrinsic semiconductor. Extrinsic semiconductor are semiconductor that have small amounts of impurities added, which we call dopants, into the pure material. The role of this dopant is to provide extra charge carrier, either electrons or holes, which increases the material's conductivity. Depending on the type of dopant, the material can have effectively positive or negative charge carrier. Even with impurities, the material still behaves as a semiconductor, which is it does not become a metal. By adding dopants, we can control and tailor the conductivity of the semiconductor for specific electronic applications. Because of this enhanced and adjustable conductivity, extrinsic semiconductors are widely used in electronic devices and components. In short, extrinsic semiconductors show how pure semiconductors can be modified to be more practical and useful in real-world technology.
One of the types in semiconductor is N-type. N-type is a pure semiconductor doped with atoms from group 5 such as phosphorus, antimony, and arsenic of the periodic table. N-type is dopant atoms have 5 valence electrons while silicon has 4. 4 electrons form bonds with silicon atoms, leaving 1 free electron. These free electrons move easily and becomes the main charge carrier, increasing electrical conductivity. The majority carriers in N-type is electrons, which is negative, and the minority carriers is holes, which is positive. Electrons in N-type are the main contributors to electrical conduction. Second type of semiconductor is a P-type. P-type is a pure conductor doped with group 3 elements, which are boron, aluminium, and gallium. These dopants have 3 valence electrons, 1 less than silicon. This creates a hole or missing electrons. The holes act as positive charge carriers, allowing electric current to flow. Majority carriers in P-type is holes, which is positive, and minority carriers is electrons, which is negative. The holes behave like positive charge and are responsible for conduction. Combining P-type and N-type materials form a pin-N junction, the basis of diodes, transistors, solar cells.
Semiconductors, when an external voltage is applied, holes, which are positively charged, move towards the negatively charged end or the cathode, in the direction of the electric field. On the flip side, N-type semiconductors, with their extra electrons, allow the flow of electrons towards the anode when exposed to an external electric field, moving opposite to the direction of the field. In essence, the conventional current flow of positive charge appears to move from the P-type to the N-type semiconductor in a circuit. When we bring P-type and N-type semiconductors together to form a p-N junction, we create a fascinating platform that forms the basis of diodes, transistors, and numerous other semiconductor devices.
For examples of semiconductor, there are microcontroller, memory card, display drivers, audio drivers, keyboard controller, transistor, and
Did you find the semiconductors hidden in his morning? Let's count one by one. The firm's elevator, the company's entrance gate, his ID card, the automatic door, the subway information signage, the escalator, his transportation card, the subway gate, his Galaxy Buds, his apartment's elevator, the door lock, the steam closet, the induction range, the refrigerator, the coffee machine, the toaster, the water purifier, the hair dryer, the LED lights, and even the smartphone. At a glimpse, in total, it's more than 20. So there must be more that we missed counting. So, can you imagine living a day without semiconductors?
Now, let's move on to applications of P-N-type semiconductors. Semiconductors play a crucial role in our daily life. Firstly, diode. It is used for rectification and current control in electronic circuits. Next, light-emitting diodes, LED, produce light and are used in displays, indicators, and lighting. Thirdly, solar cells. It is used in photovoltaic technology to convert sunlight into electrical energy. And lastly, integrated circuits, IC. It forms the basis of microprocessors, memory chips, and digital electronics.
In conclusion, semiconductors are materials with controllable conductivity essential for modern electronics. Intrinsic semiconductors are pure, while extrinsic semiconductors, N-type and P-type, have enhanced conductivity through doping. The p-N junction form the basis of devices like diodes, LED, solar cell, and ICs, making semiconductor vital for efficient signal processing and energy control in electronic systems. Overall, semiconductors form the backbones of modern electronic and digital technology, enabling efficient signal processing, energy conversion, and control in countless applications. That's all from us. Thank you.